Let's learn the proof of cos A minus B, which is equal to cos A cos B minus sin A sin B. These are called compound angle formulas. Okay. So whenever you have two angles A and B, A minus B or A plus B are called compound angles. So there are some identities in trigonometry with all these values, and you need to know the proof of all of them. It's a definite question on Leaving Cert. We have seen it repeating multiple times. So we will have to learn the proof also, and also we need to know how to do the problems related to that. So today we are going to learn cos A minus B is cos A cos B minus sin A sin B. So for that, let us take a unit circle. So what is a unit circle? A circle with a radius 1 unit. Okay. And from the center, I am going to draw two lines here. One is this one and one is this one. I'm going to mark this as P and I'm going to mark this as Q. Okay. And now I am taking this as the positive side of the x-axis. And for this proof, what I need to say is this whole angle here, that is A. Okay, and the angle which Q makes with the x-axis is angle B. Okay. So A is the angle which the line PO, like if this is the origin, PO makes with the x-axis, and angle B is the angle which OQ makes with the x-axis. So in this case, this angle is A minus B. Okay. So this angle is A minus B. So this is a specific case what we take for proving this equation. And so let me just write it. Angle POQ is equal to A minus B. Okay. Now with this we are going to work on the proof. So the proof works with two different methods. So what we need to do is, I'm just going to draw a line here, PQ, which means this PQ. Okay, this line PQ. So what I'm going to do is, I'm going to find the length of PQ in two different ways. One is the standard distance formula. And the second one is cosine rule. Cosine rule of trigonometry, triangles. Okay. So let's take the first one. Now before that, before we find out the standard distance formula, you need to find the coordinates. So the coordinates for Q in the normal Cartesian, not the Cartesian system, the polar system is, Q is nothing but cos B sin B, and P is cos A sin A. Okay, so P is cos A sin A and Q is cos B sin B. So now we are going to do the distance formula. With PQ. Okay, so distance formula with PQ will be, so P is cos A sin A and Q is cos B sin B. So distance formula will be square root of, so just for our understanding, let me just write P is cos A sin A and Q is cos B sin B. So the distance formula will be y2 minus y1 the whole square plus x2 minus x1 the whole square. So it is cos B minus cos A the whole square plus sin B minus sin A the whole square. So the formula is there in the formula book, where we all know it is a coordinate geometry formula. And now we need to expand this. So it is like cos B square, or maybe cos square B, I would write it neatly, cos square B plus, minus 2 cos A cos B plus cos square A plus sin square B, I'm just writing it down, minus, maybe I'll just write it beneath this so that we will be able to do it better next time, sin square B minus 2 sin A sin B plus sin square B. Okay, Simplifying this further, cos square b sin square a. Cos square b plus sin square b, this together will be 1. Okay, and this together, I'm not cancelling it, please note I'm not cancelling it, I'm just putting it as 1 plus 1 minus 2 cos a cos b minus 2 sin a sin b. Okay, or I can write this as 2 minus 2 cos a cos b, or I can take the 2 outside, plus sin a sin b. Okay, now the second one is we use the cosine rule. For doing the cosine rule, let me just draw the diagram once again. So this is P and Q, and you have it meeting at the origin, and P is cos A sin B, or cos A sin A, and Q is cos B sin B. Okay, these are the coordinates. So for when using the cosine rule, what you can do is PQ square is equal to, it is of the form A square is equal to B square plus C square minus 2BC cos the angle between the values. So here you can write it as PQ square is equal to OP square plus square of this and plus square of this plus OQ square minus 2OP OQ cos A minus B, because this angle is A minus B from the first unit circle. That is equal to, OP is 1 because it's a unit circle. So 1 plus 1 minus 2 into 1 into 1 cos A minus B, which is equal to 2 minus 2 cos A minus B. Okay, so this is the value. Now I have this first equation here, which is the length distance formula, which is calculated from the distance formula. Second is the cosine rule formula, the length of PQ. Now I can equate both. What I will get is 2 minus 2 cos A cos B plus sin A sin B is equal to 2 minus 2 cos A minus B. Okay, so I can cancel off 2, this 2 I can cancel off, negative also I will cancel off, and I cancel this 2 and this 2, and I get cos A minus B is equal to cos A cos B plus sin A sin B. Okay, so this is how we find the formula. Now continuing this, you can find the proof of cos A plus B, that is cos A cos B minus sin A sin B. So remember, if there is if this is negative, this will be positive. If this is positive, this will be negative. Okay, so you can memorize it like that. Now we are going to do the proof of cos A plus B equal to cos A cos B minus sin A sin B. Now for this proof, it is pretty easy, but you need to understand a couple of things before. That is, cos of minus B is equal to cos B. Okay, and sine of minus B, sine of minus of an angle will be minus sin B. Okay, so these two things you have to keep in mind before we do this. So what you do is you take the already existing proof, the proof that cos A minus B, which we proved before, cos A cos B plus sin A sin B. Okay, that's it. So you just take the previous one, and what you do is instead of B, you replace it with minus B. Okay, because that is what you have to find out. So what will happen is the equation will become cos A minus minus B is equal to cos A cos minus B plus sin A sin minus B. That is equal to, so then you can write cos A plus B is equal to, cos of minus B is cos B. So cos A cos B, then sin of minus B is minus sin B. So that minus will propagate here. So it is sine A, sine B. So this is the proof of the second one.